Hello everyone, welcome to Learn Spring Boot with Bingyang. In this video, we'll work on the user story of changing a user's password. While it may sound simple to just update the old password with the new one, don't forget that since we're using JWT, it is crucial to revoke the JWT that was created based on the old password. How do we achieve that? We'll need to use Redis, an in-memory key value store that is often used as a cache or quick response database. I will also show you how to use Testcontainers to create a throwaway Redis instance just for integration tests. Finally, we'll configure Azure Cache for Redis for our production environment. But first, let's look at this user story. Look at this user story in the user management feature. As a logged-in user, I want to reset my password so that I can ensure the security of my account. So if a user's username and password are stolen, then the user must reset her password. Okay, understanding the value of this user story, let's go ahead and implement it. Let's follow the API first approach and define a new API endpoint for this user story. Let's go to Swagger Hub. This is the API documentation of our Hogwarts Artifacts Online project. As you can see, I've already added a new endpoint, /users/user-id/password to our Swagger API document and upgraded the document version to 3.2.0. The link to this document is available in the description of this video. As you can see, this is an HTTP patch request. I believe this is the first time we use this HTTP verb. Patch is similar to put, as they are both for updating resources. Put is used for full updates, replacing the entire resource with the data provided. On the other hand, patch applies partial modifications, updating only specified fields without altering the rest of the resource. Recall that password is a field or property of the user resource. So, use put for complete resource replacements, while patch is suitable for partial updates to existing resources. Okay, let's look at the details. Besides the path variable user ID, the client needs to send a request body like this to the application. Old password, new password, confirm new password. I'm sure you're familiar with that. We have all changed our password, right? And here are some possible responses from this API endpoint. For the heavy path, that's 200, user password changed successfully. The response may be 400, bad request or invalid argument, for example. Maybe the new password does not match the confirm new password. So this is the response. Or maybe the new password is too simple and it does not conform to the password policy. So this will be the response. The response may also be 401, unauthorized. That is, the provided old password is incorrect. In the end, maybe the provided user ID is not valid, so the user does not exist, or user not found. Okay, understanding this API, let's go to IntelliJ and implement changing passwords. First, let's create a Git branch. Git branch, password, change, JWT revocation, git switch. To implement changing password API, let's start with the controller method. Recall that this is a patch mapping. Add patch mapping password, public result, change password. First, we need to retrieve the path variable, user ID, at path variable, integer, user ID. So just make sure that this parameter name matches the path variable. Okay. Then how do we retrieve the request body? Recall that the request body has 3 key value pairs: old password, new password, confirm new password. Well, here, let's use a map object as the formal parameter of this control method and annotate it with @requestBody. @requestBody. And the type is a map. Key is a string, value is also a string. And let's call it password map. Well, so this looks good. We don't need this. And here we need to retrieve the confirm new password as well. String confirm new password. And we do not need this. All right, so let me remind you the purpose of this annotation @requestBody. It gets the HTTP request body and then deserializes the request body into a Java object, in this case, the map object. And to be more specific, it is the Spring Web MVC that binds the HTTP request body to this map object in the controller method. So inside the method, we retrieve the 3 values and we pass user ID and the 3 values to this .userservice.changePassword. We don't have this method yet, don't worry. And finally, we're going to return a result: true, success, change password success, and there's no need to include the data. We just need to inform the front end, change password success. Next, let's implement this change password method. For the user service.changePassword method, let's take a TDD approach, or test-driven development approach, and think about what can go wrong first. So let's go to the user service test. Let me split the screen. Well, the first one should be a happy path. So let's call this test. Test change password success. Keep going. Let's think about what can go wrong, because that's the fun part. Based on the API documentation, it is possible that the provided old password is wrong. All right. So test change password, old password is incorrect. What else? The new password does not match the confirm new password, right? At test change password, new password does not match confirm new password. Maybe the new password does not conform to password policy. So test change password, new password does not conform to policy. Last but not least, void test change password user not found. All right. So as you can see, for this very simple functionality, there are multiple ways that can go wrong. Okay, so with this in mind, let's come back here and implement this change password method. Okay, cool. Thank you, Copilot. So for this one, let me add a comment. If the old password is not correct, throw an exception. And let's change this exception to bad credentials exception. Then change the message to make it consistent with the API documentation. So you must review the AI generated code very carefully and not just take it as is. All right, so here, if the new password and the confirm new password do not match, throw an exception. And the message is new password and confirm new password do not match. While here, Copilot missed one test case. That is, the new password must conform to a password policy. For example, contain at least one digit, one lowercase letter, one uppercase letter, and we do not need a special character. Okay. Now get to work, Copilot. All right, so let me extract this. And let's call this password policy. And here we can simply just use this message. New password does not conform to password policy. Okay. And here, encode and save the new password. Now recall that never save plain text password in your database. All right, I'm not happy about these two exceptions. Let's create our own custom password change illegal argument exception. So let's go here, find system, exceptions. As you can see, we already have some custom exceptions. Let's create another one. Let's call this password change illegal argument exception. Extends runtime exception. That's okay. Then here, let's replace these two illegal argument exception with password change illegal argument exception. Copy and paste here. Now let's also handle these two exceptions in here, exception handler advice. So at exception handler, password change illegal argument exception.class. Good. Very good. All right, next, let's complete the test cases. Let's work on the first test case. Test change password success. Given when and then. Now recall that the given step is where we prepare some fake data and define the behavior of the mocks. So first, let's create a fake Hogwarts user that is returned from the database with the encrypted old password. Hogwarts user, new Hogwarts user. Okay. So let's assume that we're trying to change Eric's password, and 2 is Eric's user ID. And also, we need to set Eric's password encrypted old password. So this is the fake user. All right, next, let's define the behavior of the first mock, this.user repository. And this is good. When this.user repository.findById2 is invoked, don't go to the database to retrieve the user. Instead, return this fake user with this fake encrypted old password. Recall that in unit test, we want isolation. We must clearly define and mock the behavior of the dependencies. In this case, this.user repository. Well, actually, user service has more than one dependency. So this is one. And inside, we have also used this.passwordEncoder.matches. So this is great. But let me change this one to any string for simplicity. To make sure that this matches always return true. Because here we're testing the happy path. If I scroll down, I believe we used another method in password encoder right here. This.passwordEncoder.encode. We also need to mock this behavior. All right, good. And finally, we need to mock the .save method. Then in the when part, now recall that when is where we call the method on the test, which is the change password. So this dot user service dot change password. This is good. Let me change the old password to unencrypted old password. And make sure the new password conforms to the policy. ABC12345. ABC12345. Okay. Now in the then part, which is also known as the assertion part, is where we compare the result of this call with the expected result. All right, so assert that Hogwarts user.getPassword is equal to encrypted new password. Because here we already defined the behavior of the encode method. And let's also verify that .save Hogwarts user is called exactly once. Okay. So let's test this. All right, it passed. Good. Then let's quickly define other test cases. So they have very similar code. So let me copy that, paste here. So this is old password is incorrect. And here we need to change this one to false. And we do not need this to, because an exception will be thrown. So here, let's define the fake exception. Assert throws bad credentials exception.class. So this is the wrong old password. And new password, confirm new password, that's good. And let's delete this win part, because this is the win part. Then here, let's receive this exception. So in the then part, we can make some assertions. So assert that exception is instance of bad credentials exception.class, and also dot has message old password is incorrect. All right, so let's test this. All right, passed. Keep going. Let me copy this. Paste here. Now this time we're trying to test new password does not match confirm new password. So here, let's change this one to the correct unencrypted old password. So this is ABC12345. And this one is ABC12345. And I accidentally put an extra 6, so they do not match. And this time, it will throw password change illegal argument exception. So same thing here. New password and confirm new password do not match. Okay, then here, make sure this is true, because this time the old password is correct. It is just the new password does not match the confirm new password. All right, let's test. All right, it passed. All right, let's keep going. Now this time, new password does not conform to policy. So let's first make sure they match, and then let's change to a very simple password. For example, short. And this time, the message will be different. New password does not conform to password policy. Okay, so let's test. All right, it passed. Now, finally, let's copy this. Paste here. Test change password user not found. So we do not need this user. And this one will return optional dot empty. And this will be object not found exception. And here, it doesn't really matter what the new password is, but let's just make it the correct one. Object not found exception. And the message is could not find the user with ID 2. All right, so let me delete this. All right, and here we do not need this. And let's test. And it passed. Good. Next, let's go to security configuration and add an extra authorization rule. Dot request matcher HTTP method dot patch this dot base URL plus. That's good. Recall that this authorization manager defines the authorization rule such that a user can only change her own data, in this case, her own password. So Eric cannot change John's or Tom's password. However, admin can change everybody's password. We discussed this authorization manager in the previous video. All right, we're done. Next, let's test in Postman. And then let's come back to IntelliJ and write some integration test cases. Let me launch my project first. Let's go to Postman. All right, let's log in as Eric. Okay, so let me copy this token and then create an API call to change the password. So let's pick patch, and the URL is localhost API v1 users. Eric's user ID is 2, and then password. Let's go to authorization and pick bearer token. Paste the token we just got from here. Let's go to body, raw, and prepare the request body. The first key value pair is old password. It is 654321. New password ABC12345. Confirm new password ABC12345. All right, let's click send. Change password success. Now let's go back to the login and try to use the old password to log in. So click send. Now this time we got bad credentials. Now if I use the new password, ABC12345, click send. All right, as you can see, login success. Great. But as you know, we do not want to test like this, right? Let's go back to IntelliJ and write some integration tests. Now I'm in class Hogwarts user controller integration test. So let's scroll all the way down. But let me copy the last test case. Test delete user, no access as role user. Just copy and paste it here. Now, of course, we need to change this name to test change user password success. All right. Check change user password with valid input. And by the way, this is a patch. All right, and here let's add dirty context. All right, so let me delete this one and only keep this part. So first, here we log in as Eric. Then let's try to change Eric's password. But first, let's prepare some data. Given map string password map new hash map old password new password ABC12345 password map dot put confirm new password. All right, then we need to use this dot object mapper to convert it to JSON. Password map JSON. Okay, next, let's send it out using this .markmvc.perform, but this is not a delete, it is a patch. And this URL should be /users/2/password. And we also have a content type, because this markmvc will send this password map JSON. And apparently this is media type.json dot, and the content is password map JSON. And we accept JSON. Now here is the JWT of Eric. According to the API documentation, this one should be true. This one should be success. And the message should be change password success. And the data should be null, so don't worry about it. Okay, so let's launch the test case. Okay, it passed. Good. And let's continue. Copy this. Paste. And this time is test change user password with wrong old password. So let's change this one to 1234556. Apparently that's not the correct password. So this time we should get false. Should be 401. The message is username or password incorrect. And this time we have a data which is old password is incorrect. Everything else is the same. All right, so let's test. Good. Copy this for the next test case. This time is with new password not matching, confirm new password. So this is 1, 2, 3, 4, 5, 6. But here we have to provide the correct password. Invalid argument. And the message is new password and confirm new password do not match. All right, let's test. Good. Let's continue. Now this time is new password not conforming to password policy. All right, so let's make it short. And the message is new password does not conform to password policy. All right, so let's test. Okay, good. All right, finally, the last one. User not found. So for example, here, let's change it to user with user ID, for example, 6. And you know that there's no user with user ID equal to 6. Okay, so let's make sure this is the correct password. Should be 44. Could not find user with ID 6. All right, so let's test. The test case failed. Actually, Spring Boot returns 43, access denied, thanks to the authorization manager we defined in the previous video. The currently logged in user, Eric, in this test case, cannot change other users' password. That's why we got 43, access denied. To fix this problem, we can remove the code from line 434 to line 438, and then use John's JWT to log in. Since John is the admin, then we can get a 404. However, here I choose to simply just remove this test case. Feel free to keep it if you like. So let me get rid of this. So we're done changing password. Now let's work on revoking JWTs. But let's go to the slides first and talk about why do we need to revoke JWTs. Let's briefly review our current authentication process. The client submits username and password to the Spring Boot application. Through basic auth, the application creates the token and returns the token to the client. The client will save this token locally and attach it to subsequent requests to our Spring Boot application, like this. For example, the client wants to get all the wizards from the application. Spring Security will verify this token first. If the token is validated, grant access to this request. You already know this. However, there is actually a problem in this process. Let me show you in Postman. I just restarted my Spring Boot application. So here is Eric's username and password. So let me log in as Eric. And here is the token. Let me copy this. And let's say Eric wants to get a list of wizards. So here is the API, and let me paste the token here. So remember this token. The last 4 characters are V5CW. Let's click send. All right, great. We got a list of wizards. So this token works. No surprise. Next, let's change Eric's password. And same thing. We're going to paste this token, V5CW, and come here to the request body. And we're going to change Eric's password from 654321 to ABC12345. All right, so let's click send. All right, change password success. Now let's go back to the login. Now apparently we cannot use this old password. We need to use the new password, ABC12345. Click send. All right, now we got this new token. Here is my question. Does this old token, V5CW, which was created based on the old password, still work? Let's see. So let me click send. All right, it still works. Send again, again, again. So this old JWT still works. And that's a problem, because the whole point of changing password is to prevent someone who steals your password from accessing your account immediately from the moment the password is changed, right? But remember, when we created a JWT, we set its expiration time. And in my application, it is 2 hours. That means even though we changed the password, it is possible that a hacker can still use a previously generated JWT for as long as 2 hours. That is horrible, right? Also, think about a different scenario. If you are the admin and you deactivate a user because this user has been laid off, then what should happen is this user will lose access to the system immediately. However, if this user has a token previously generated and saved in her browser, then she could still access the system until the token expires. This is not acceptable. We want to revoke all previously created JWTs upon changing password or updating a user's status. How to solve this problem? Let's go back to the slides. Here is the updated process. The client submits username and password to the Spring Boot application. Through basic auth, the application creates the token and returns the token to the client as usual. But at the same time, we will also save a copy of the token to the Redis cache. And in Redis, we maintain a whitelist for tokens. So as you see, now we have 2 copies for the same token. One is stored locally in the client and one in the Redis cache. The client attaches the token to the subsequent requests like this. For example, the client wants to get all the wizards from the application. What happened afterwards is that besides the regular Spring security authentication process, we will need to query the Redis to ask, do you have a record of this token? If the answer is affirmative, then grant access to this request. So there is an extra step after Spring Security validates the token. Will this solve the problem? Let's look at the scenario of password change. As usual, creating the token, sending it back to the client, and save a copy in Redis. Now, at this moment, the client realizes that her password has been compromised. So she decides to invoke the changePassword endpoint. Okay, no problem. Spring Boot verifies this is a good token. And it also exists in the Redis cache. So password is changed. Great. More importantly, upon password change, we will remove this token from Redis. As you can see, the token is removed from the whitelist. Only the client has a copy of this token. And we know that this token was made based on the old password. Next, this client wants to use this old token to access, for example, the /wizards endpoint. The token arrives at the application, but this time, even though Spring Security thinks this is a valid token, this token is not in the Redis cache. So access is denied. Next, let's go to IntelliJ and implement revoking JWTs created by old passwords. Since we will be using Redis cache, let's set up the development environment first. The best way to create a local Redis instance for development purpose is through Docker Compose. So here, let's define a Redis service in docker-compose.yaml file. Redis. Okay, that's it. Line 26 to 29 will start a Redis instance exposed on port 6379. Let's fire it up. but make sure your Docker is running. This is very important. I'm using Docker desktop, so make sure that application is up and running. Okay, so let me click this run button. You can fire up all the services I defined here by using docker compose up command. But in this case, I only need one service. So just click and start. Well, if this is your first time running the Redis, Docker Compose will first download the Redis Docker image and then start the container. I have already run Redis several times, so it's pretty fast here. Okay. As you know, Redis is a key value, NoSQL database. So is there a client that we can use to connect to Redis to visualize its content? IntelliJ provides a Redis client so that we can connect to Redis inside IntelliJ. Let's click here, Database, click Add, Data Source, and let's find Redis right here. You may also need to download the Redis driver if this is the first time you use Redis in IntelliJ. So let's test connection. It is good. Apply and click OK. Now we have access to the Redis instance in Docker. Now, as you can see, right now it is empty. Okay, so let me close this. So the Redis is running. Next, let's configure Spring Boot to connect to this Redis instance. Let's add a dependency in pom.xml. Dependency, the group ID is org.springframework.boot. The artifact ID is Spring Boot starter data Redis. Okay, so make sure we load Maven changes. Then let's go to application-dev.yaml and configure Redis connection settings. Let's come to here. Data, Redis, host, localhost for dev purpose, and port is 6379. All right, good. That's all for configuration. Next, let's write some code to connect to Redis service. Let's go to client. Recall that in this client package, we defined third-party or external services. So let's create a package called Redis Cache. And under this package, let's create a new class called Redis Cache Client. We're going to use this Redis Cache Client to operate the Redis Cache in Docker. All right, so first, let me define a private field, private final, string Redis template from org.springframework.data.redis.core. Recall the dependency we just added in pom.xml. So that's the class. So this string Redis template class is a Redis template provided by Spring Data Redis for working with string keys and values. When the application is started, Spring Boot will automatically inject an instance of this string Redis template into this class. All right. Then what are some possible interactions between our Spring Boot application and this Redis cache? CRUD, right? So we can save something in Redis, we can retrieve something from Redis, and we can delete something from Redis. Let's only define set, get, and delete. So thank you, Copilot. We have the set, we set a key and a value, but also we would like to put a timeout for each key value pair. So here is long timeout. We also need time unit. So same thing here. So this set method stores a value in Redis with a specified timeout. Now inside the method, we're invoking the Redis template.ops4value.set, which ultimately sets the key value in Redis with a timeout. So if you know design patterns, this Redis cache client is really just a proxy for this string Redis template to make it easier to use. So you just call set instead of using this.Redis template.ops4value.set, which is pretty verbose. All right, next, let's define get. We also have delete. So that's for delete. We also need a method to check if a user's token is in the whitelist stored in Redis or not. So let's call this public boolean is user token in whitelist. And we pass user ID and this token to it. So here we have string token from Redis, this dot get user ID, but we also want to add a prefix whitelist colon, and then return token from Redis is not null. That's good. So let's make this name more self-explanatory. Token from an incoming request. So recall this picture. The token from request is the token provided by the client. In other words, the token stored locally in the client's machine. And this token is retrieved from Redis. So we're trying to compare if they're equal or not. But before that, we need to make sure that this token from Redis exists. If it doesn't exist, then there's no need to compare. In summary, if we can find this user's token in the whitelist in Redis, and it is equal to the token from request, return true. Otherwise, if we cannot find this user's token in the whitelist in Redis, or if we find it, but it is not equal to the token from request, return false. And don't forget to annotate this class as a Spring Bean. So add service. Okay. Next, let me ask you, when should we save the token or set the token in Redis? Recall from this picture, we need to set the token in Redis upon successful login. So let's go to the auth service. As you know, in create login info, we created this token and then return this token to the controller, and the controller returns it to the client. So before we return the token to the client, let's save the token in Redis. And the key should be something like this. Whitelist, colon, user ID, value will be the token. Okay, so before we do that, we need to make sure we inject Redis cache client into this class. Add constructor parameter. So here we can use this dot Redis cache client dot set. Okay, so that's the key and value. Let's make it expire in 2 hours. Now think about this. If a user logs in multiple times, will there be multiple key value pairs for this user in Redis? No, there won't be multiple tokens because the key is unique. So if a user logs in multiple times, only the last JWT will be kept in Redis. Now let me start my application and test in Postman. And let me open Redis client, refresh. As you can see right now, there is no key value pair. Close this. All right, let's go to Postman. Let me log in as Eric. Great, we have this token. The last 4 characters are 2v-w. And let's go back to IntelliJ. Refresh. All right, now we have one key value pair. The key is whitelist : 2. If I double click, and this is the token. 2v-w. Okay. Now if I log in again, now this time it is 9bhg. Here, if I close this and refresh, now this time this JWT overrides the previous one. What about I log in as John? Now I have 2 key value pairs. As you can see in Redis, we keep a whitelist of logged in users. Next, let's talk about removing tokens from Redis or deleting tokens from Redis. So let me ask you, when should we delete the token from Redis? Recall from the slides, when a password change is detected or a user status update is detected. So let's go to the user service class. So here, before we save the updated user, let's revoke this user's current JWT by deleting it from Redis. That means we need to inject Redis Cache client into this class. This dot Redis Cache client dot delete. Here is how we form the key: whitelist : plus user ID. Is from here. All right. And recall that if an admin deactivates a user, we should also revoke the JWT. So let's scroll up. And here is the update. This is for regular user, and this is for admin user. So after the admin changes a user's username or is enabled or roles, we should immediately revoke this user's current JWT. In this case, the user will have to log in again if any of those information is changed by the admin user. All right, next, for every request to a protected API, we need to extract the JWT and verify its presence in Redis. Recall this picture. So how do we intercept each incoming request in Spring Boot? The answer is Spring interceptor. So let's create an interceptor. Let's go to security new a Java class. Let's call it JWT interceptor. Implements handler interceptor. And annotate it as @component. Okay. So what is an interceptor? An interceptor intercepts and processes incoming HTTP requests and outgoing responses at a global level before they reach the controller or after they leave the controller. For us, we only care about intercepting incoming requests. In other words, interceptor will process a request before it hits the controller method. And that's a perfect time for us to verify if the token is present in Redis or not. And here's how we do that. After implementing this handler interceptor, we need to override one method called pre-handle. So this method gets called before the request hits a controller method. So let's delete this part. So first, we need to get the token from the request header. If the token is not null and it starts with barrel space, then we need to verify if this token is present in Redis. Else, this request is just a public request that does not need a token. For example, login, register, and so on. Okay, so that's the basic algorithm. Next, let's implement this. First, let's get the token from the request header. Now, as you can see, request is one method parameter. So we can do this, request.get header authorization. So this is the authorization header. Okay, if authorization header is not null and it starts with barrel space, then let's retrieve its authentication. So here, security context holder dot get context dot get authentication, and next authentication dot get principal, and we know that this principal is of type JWT. Recall that when we query the Redis cache, we need user ID as the key. Okay, next, we need to retrieve the user ID from the JWT claims and check if the token is in the Redis whitelist or not. String user ID, get claim, user ID. All right, so recall that get claim will return user ID as a long value. So we'll have to cast it to string. Okay, if not, this dot Redis cache client dot is user token in whitelist. So user ID, and here is JWT dot get token value. So we're going to pass these two values to this method to verify if this key-value pair exists in Redis. If this pair does not exist in the whitelist in Redis, throw new bad credentials exception, and the message is invalid token. Well, for Spring Security, this may be a valid token. Since the token does not exist in the whitelist in Redis, we consider it as invalid. Okay, then here, return true. So basically, in pre-handle, if the request has an authorization header with a bearer token, then in the if body, we need to verify if the user ID and the token exist in the Redis whitelist. Otherwise, this request is just a public request that does not need a token. So return true means just let the request pass this pre-handle without disturbing it. So that's the whole purpose of interceptor, is that it gives the developer a chance to do some pre-processing before the flow goes to the controller method. Now, in our case, if the user token is not in the whitelist, then we'll stop the flow by throwing an exception. So this request will never get to the controller method. Otherwise, we just let it pass. Here, I also want to point out something. In a Spring application that uses both Spring Security and interceptors, like this case, Spring Security is invoked before the Spring interceptors. This means that when the request reaches a Spring interceptor, this request has already been authenticated and authorized by Spring Security. That explains why we can retrieve the authentication from the security context in this interceptor. Next, we need to register this JWT interceptor in Spring Boot. So in system, let's create a new class. Let's call it web config, and it implements web MVC configurer. Let's make it a configuration. Add interceptors. Okay, so first let's inject JWT interceptor. Registry.add interceptor, this dot JWT interceptor dot add path pattern, all the requests. So basically it means that this JWT interceptor will intercept all incoming requests. There is another useful API here, which is this one, exclude path patterns. So if you use this one, this interceptor will intercept all requests except for the specified path you put here. But in this case, we'll use add path patterns. So we intercept all requests. Next, let's test in Postman. Let me start my project. Let's go to Postman. Let me log in as Eric. So let me copy this token. And let's go to Wizards. Put the token in. Click Send. All right, great. Next, let's go to changePassword. Put this token in. Here in the body, we're going to change the password to ABC12345. Click Send. All right, change password success. All right, now let's come back here. Can we still use this old token? Let's try. Click Send. All right, it has invalid token, right? So good. Now let me log in, use the new password. and use this new JWT here, it works. So the old token does not work, the new token works. Great. Next, let's go back to IntelliJ and fix unit tests in user service test, because we introduced the Redis cache client. Since we added line 114 in changePassword method in user service, this Redis cache client.delete will break our current user service tests. So let's mock the behavior of Redis cache client.delete. So in test changePassword success, let's write do nothing dot when this dot Redis cache client dot delete any string. However, we do not have this Redis cache client in the user service test class yet. So let's scroll up. After this, let's define one more at mock. Let's scroll down to the test case. Okay, just remember to add this line in test changePassword success. We do not need this for other exception test cases because they will never get to this line. So they will stop in the middle. So no need to add this line to other test cases. By the way, we do not need the last one, user not found. So let's delete that. Then let me launch all the test cases in this class, user service test, to make sure everything's okay. Okay, great. Next, let's run all the tests. All right, all tests passed. Now, the reason all tests passed, especially those integration tests, is that I have Redis running in Docker. Next, let me turn off Docker and rerun all the tests. So now my Redis is down. Let me rerun all the tests. All right, what happened? 44 test cases failed. Well, if you look at them, all of them are integration tests. So here are the integration tests for wizard, integration tests for user, integration tests for artifact API. But other unit tests, they all passed. So what's going on? Well, the problem is that our Spring Boot is trying to connect to Redis. But as you saw, I turned off Redis. So Spring Boot cannot connect to Redis. That makes logging in impossible. Recall that logging in depends on Redis to save the token, right? And you're like, all right, that's life, right? Then let's just remember to start a local Redis Docker container before running all the integration tests. That's not hard. But this is not convenient, since we need to remember to turn it on and off before we can run all the tests. And developers always look for ways to make life easier, not harder. So next, let me introduce Testcontainers. Testcontainers is a library designed to facilitate integration testing by providing lightweight, disposable instances of common services, such as databases, message brokers, or web browsers within Docker containers. So we're still using Docker. The first prerequisite to using any test container is to have Docker installed on the machine where we're running the test cases. Since Docker is a no-brainer for development, I'm sure every developer should have Docker installed and running during development. Test containers works well with JUnit and will automatically set up and tear down of containers during the test lifecycle, making it easy for us to manage dependencies and maintain clean test environment. It is especially useful for writing integration tests that talk to a real backend service, such as MySQL, PostgreSQL, Redis, MongoDB, and so on. So let's go back to IntelliJ and add test containers in Spring Boot. To use test containers with Redis in Spring Boot, we need to add 3 dependencies in pom.xml. Here is the first one, org.springframework.boot Spring Boot test containers. And also, let's put a scope, test. The second one is from org.testcontainers JUnit-Jupyter. And also, scope is test. Okay, for the third one, let's go back to test containers website. As I said, test containers support many services. So let's go to the modules and search test container support for Redis. Okay, as you can see, so here we have the Java example. Let's copy this, come back here, paste here. Okay, so those are the 3 dependencies that we need for integration tests. The first 2 are general, and the last one is specific to Redis. All right, and let's click Load Maven Changes. Let me close this and go to the integration tests. So here is one, here is one, and here is one. Here is how we use test containers in this integration test class. Let me create a static field, and let's call this Redis container from com.redis.testcontainers. All right, here is Redis container equal to, let me go back to the website, copy this, paste here. Okay, and that's not enough. We need to add 2 annotations. First one is at container from org.testcontainers.junit.jupyter. Also, we need to add a class level annotation at test containers right here. So this at container annotation indicates this is a test container instance. Now, there is another important annotation. It's called at service connection from this package. All right, so now we're done. Let me explain. A service connection is a connection to any remote service. This powerful annotation allows, in our case, this Redis cache client, or to be more specific, this string Redis template, to communicate with Redis instance running inside the test containers managed Docker container. Behind the scenes, this annotation figures out the kind of container that is annotated, and it creates a connection details bin for it. In our case, the bin is a Redis connection details. The Spring Boot then configures the driver to connect to Redis running in the test container. If you're interested, let's briefly look at this Redis connection details. It's right here. As you can see, it extends connection details. And we can find its implementation, which I do not think there are many. And let's look at the first one, properties Redis connection details. And let's click into the Redis properties right here. All right, as you can see, the default host is localhost, and that's the default port. And Spring will use those properties to connect to the Redis test container. Let me close those. All right, next we need to do the same thing to the other two integration tests. So let me copy this. Go to here. All right. Next, let me launch all the tests. Again, make sure your Docker is up and running. Okay, all tests passed. Good job, Testcontainers. All right, as our last task, let's create Azure Cache for Redis to prepare for production. Let's go to Azure Portal. Let's provision an Azure Cache for Redis. Let's search for resources, Redis, and click Azure Cache for Redis. Let's create a new one. Hogwarts resource group. And let's enter a name. And for cache SKU, let me pick the cheapest, basic, no SLA. Let's go to next. That's okay, next. Microsoft intro authentication is recommended. Next, review and create. Let's create. It will take a while. While the deployment is in progress, let's go back to IntelliJ and configure Spring Boot to connect to Azure Cache for Redis. Let's go to pom.xml. And add another dependency. This time, the group ID is com.azure.spring. And the ID is Spring Cloud Azure Starter -data -redis -lattice. Okay, so let's load Maven changes. You also need this bill of materials, this part, in case you don't have it. And let's bump the Spring Cloud Azure version to 5.14.0. All right, so let's get rid of this. All right, so this is the dependency. Next, let's go to application-prod.yaml to configure Spring Boot to connect to the Azure Cache for Redis. So here, after JPA, we need to define the connection settings. Data, Redis, host, And this time we're not using environment variable. Let's use secret from Azure Key Vault, Redis host. For the port, let's use 6380. And it also needs a username, which is also a secret from Azure Key Vault. And then let's enable SSL, enabled true. And also here we have Azure passwordless enabled is true. Okay. Recall that Azure Cache for Redis offers a password-free authentication mechanism by integrating with Microsoft Entra ID. This is the recommended approach. So recall the naming convention. If it's all lowercase, connected by hyphens or dashes, then it's a secret from Azure Key Vault. If it's all uppercase, like this, connected by underscores, that's an environment variable. Okay, so that means we need to set 2 secrets in Azure Key Vault. And we'll get these 2 values when the Azure Cache for Redis is fully deployed. Next, let's go back to the Azure portal and see if the deployment is done. Okay, it is still in progress. Let's just be patient and wait.
2,000 years later.
All right, finally it's done. Let's go to resource. So first, let's copy the host name. And then let's go to Azure Key Vault. And let's create a secret. Redis-host. Paste the value. Create. Then where do we get the Redis username? As you can see, we don't find the username here. Here is how to get a username. So let's go to Settings and click Authentication. So here, we need to search our Azure web app that hosts the Spring Boot. Recall its name is Hogwarts Artifacts Online, this one. So select this as a Redis user and click Save.
2,000 years later.
Okay, and then let's copy this username here. And let's go to Key Vault. And here let's create Redis username, paste, and create. All right. So make sure you add these 2 secrets in our Key Vault, Redis-host and Redis-username. All right, that's all. Next, let's go back to IntelliJ, commit and push the code to GitHub. Then in production, our web app will connect to the Azure Cache for Redis. Okay, let's commit and push the code to GitHub. Git commit. Implement change passwords and revoke JWTs. Git push. Okay, then let's go to GitHub. Let's compare and create a pull request. As you can see, this triggers a Maven build. During this build, all tests will be executed. Wait a minute, we didn't install Redis on GitHub. Then will the build fail? Don't worry, our project is using Testcontainers to run all the integration tests. Testcontainers libraries require a valid Docker environment in order to run the tests. As GitHub Actions by default provides a Docker environment, Testcontainers will work just fine. So during integration test, a temporary throwaway Redis instance will be created by Testcontainers.
2,000 years later.
Build is success. Let's go to pull requests. Now it's time to merge pull request. Confirm merge. And this will trigger the deployment.
2,000 years later.
All right, great. The deployment is done. And there you have it. We have successfully implemented a secure password change functionality in our Spring Boot application and ensured that all JWTs issued with the old password are revoked. This approach significantly enhances the security of your application by preventing unauthorized access with outdated tokens. Let's go back to the slides and do a quick summary. To recap, we implemented the password change API endpoint, set up our development environment using Docker Compose for Redis, and implemented storing and revoking tokens in Redis. We also covered how to use Testcontainers for integration testing and configured Azure Cache for Redis for our production environment. I hope you found this video helpful and that it gives you the confidence to secure your own applications more effectively. See you in the next video.